Hello, fifth grade mathematicians. I know it's going to be a little weird today. You're going to hear me, but not see me because we need to focus on the worksheet. This is the worksheet you should have pulled off of the internet so you can follow along today, and then I'll have something for you to try tonight. Okay, so let's get started with our review about area. So our practical applications that we spoke about yesterday, things that we measure in area would be like our front yard. In case we wanted a lawn service to come in and spray fertilizer on our front yard, we would have to know the area to know exactly how much we were going to be charged. Then also, like if you were painting a wall, you would need to know the area of the wall in order to get the right amount of paint. And then also with a bedroom floor, if you were getting new carpet or new hardwood floor or new tile, you would need to know the area to know how much flooring you would need. And also it would be for the installation fee too. Okay, so now, what if we had an odd shaped room? How in the world would we be able to find the area of the odd shaped room in order to figure out how much flooring we would need? Well, that's what we're going to do today. So it says here, work out the area of the following shapes by dividing them into rectangles. They are not to scale. So what they're saying is that this is not really in centimeters because this, we've got meters here. So you can see that they're not to scale. That's what they're talking about. Okay, so let's get started. So we've got number one. So number one, if I take a look at this, I'm trying to figure out how can I divide this up and get two distinct rectangular shapes. Well, I see this down here. I could probably fill in this part with a line and I'd have a rectangle here and a rectangle here. So that's what I'm going to do. So I'm going to go ahead and draw my line across to show that I have two rectangles. Now that I did that, some of the numbers look a little confusing. So we have to determine which numbers we still will need to use and which ones that are broken up now. So I'm looking here and the line doesn't affect this right here. And the line doesn't affect this right here. So when I go down here and I draw this with my finger, here, this line used to be 10. When we didn't have that line, this was 10. Well, now that we've broken that up, and I know what I know about rectangles, I know that this part of the rectangle and this part of the rectangle are equivalent. So this part of the rectangle is 3. So this line right here with the 10, this 10 now is broken up. So I might want to go ahead and put like a box around that to remind myself that that one's broken up and that number I'm not going to use anymore. Because actually that number now is 3 up here, and down here for this part, this is equivalent to this, and so this part is going to be 7. So I've got 3 and 7, which that gives me the 10. So that's where the 10 is now broken into, okay? So now I'm going to go up to the front rectangle, the front one up here, and I'm going to figure out the area of that rectangle first. So I remember that my formula is, and I have it right down here, length times width. So my length is 8. My width is 3. So now all I have to do is multiply that in order to get the area. So I've got 24 centimeters. And remember, this is a two-dimensional shape, so it is squared. Now, I'm not done yet because I still have this part I haven't found the area of. Now, when I'm finished finding the area of this one, I'm going to have to put these two together by adding them. All right, so here we go. So this next one down here, again, I have the box around the 10 to remind myself that that's not the number I'm going to use because now it's broken into 3 and 7. So I'm going to use the number here that hasn't been broken up. So I've got 7 for my length and 5 for my width. 7 times 5, and that's a basic fact, 35 centimeters squared. All right, so now what I have to do is I have to put the areas of both of these rectangles together. So I put 24, 35 together, and I've got 59 centimeters squared, or square centimeters. Okay, so that's the answer to number 1. So hopefully you're seeing how we're looking for how to break the rectangles, break the figure up into 2 distinct rectangles. Use that to find the area of each one, and then put those together to find the area of the whole thing. So if I wanted to buy flooring, and this would be like for a dollhouse, right? I would need 59 square centimeters, or 59 centimeters squared. Okay, so let's go on to number 2. Remember, the first step is to find out how I can break this into 2 distinct rectangles. So I'm looking at this and I'm noticing here there's a little cutout right here. So right here where the cutout is, on the first one, that's where I drew my line. So I'm going to draw my line here to get the 2 distinct rectangles. Okay, so now I have a rectangle here and I have a rectangle here. All right, so I notice that this part is 6, this part is 7. So I can go ahead and I can figure that. I've got 7 times 6 gives me 42 centimeters squared. All right. Now, I notice here, when I break this up, this used to be 10. I'm not using that 10 anymore. This part is 6. So I know if I draw my line all the way over to the end, I'm going to have, and I draw it all the way over, that this is going to be the same length as this. So if I put, I'm going to put just a little dotted line here. If I added this part to it, this whole thing would be 10. Well, 6 plus what gives me 10? Well, 6 plus 4. So I know that this part right here is 4 centimeters. Okay, I'm going to go through that with you one more time. So if I were to draw a line all the way across this line and go all the way to the end, this line would be equivalent to this line. So that would be a total of 10. I already have 6 right here. So I know 6 and 4 more would give me 10. So that's how I got my the length for that little piece. So now I can do length times width. So length times width gives me 20 centimeters squared. All right, so now all I have to do is put these 2 areas together to find the total area. So now I've got 42 centimeters squared plus 20 centimeters squared, which gives me a grand total of 62 centimeters squared. Okay, so now I know the whole area of that figure. So if that were the area of a dollhouse and I was putting carpet in the dollhouse, which when I was little, I actually did do that. I had carpet squares and I had to cut them because they were irregularly shaped rooms. So if I were to cut that, I would need 62 square centimeters, or 62 centimeters squared. All right, now we're going even smaller, millimeters. All right, maybe this is the house for the littles. I don't know. So we've got, for number 3, 30 millimeters, 5 millimeters, 20 millimeters, and 7 millimeters. So I've got this irregular shape, but I notice if I draw a line right here, I can get 2 distinct shapes. So that's where I'm going to draw my line. Okay, so I have my line drawn, and I have my 2 distinct shapes. So I notice right here, okay, I've got 20, and right here I have 5. So I know that this part and this part are equal. So I'm going to go ahead and draw my symbols so I remember that this is 7. Now I know this part and this part are equal. Draw my symbols. So I can figure out this part because I've got 7 here and I've got 5 here. And when I add those together, I have 12. Okay, so I know what these are, and I know that this part right here is 20, and I have to figure out this section right here. This section, when I figure that out, I know that the whole thing here is going to equal 30. So I know 20 plus 10 gives me 30. So 10 plus 20 gives me 30. So I can use this information in order to figure the area of each one of the rectangles. So I'm going to need the 7 and the 10. I'm going to need length times width. So I've got 7 times 10 gives me 70 millimeters squared. And then here I need the whole line. Now here it's broken up, so I'm going to use the value of the whole line. So I've got the length of 30 and the width of 5. So 30 times 5 is 150 millimeters squared. So now I need to add these up. So I've got 150 plus 70 would give me a grand total of 220 millimeters squared. 220. All right. Moving on to number 4. Number 4, I'm looking at that, I'm trying to see how I could break that up to make that 2 distinct rectangles. I think I'm going to go ahead and do this right here. All right, so right here, if I draw that line right here, I need to figure out what this line is going to equal, because I have my length, but I don't have my width. So if I have 4 right here, and this line is going to be equal to this line, these two are equal. So I've got 4 and 2 more. 4 and 2 is 6. So this is going to be 6 meters. Okay? All right, so now we can go ahead and we can determine the area of each individual rectangle. So I've got 7 times 6, which gives me a grand total of 42 meters squared. And then I have this smaller rectangle. I've got 1 by 2. So 1 times 2 is 2 meters squared. So then I just have to take the 2 and add them up, which would give me a grand total of 44 meters squared. All right, so this is a brief description of how to take an irregularly shaped object, break it up into rectangles in order to find the area. So this is the one that we were doing together, and you'll see that there are 4 more problems that look very similar to this for tonight that I want you to work on, and then I want you to bring them back tomorrow. We'll go over them, and then I will have an assignment for you tomorrow. Okay? So please work on those tonight, so when we go over them, you're not doing them for the first time, and you can see how much you really understand. If you don't understand, then you can email me, you can contact me, and I will get back to you, and I will explain more so that you'll be ready for the assignment tomorrow. All right, I want you to keep watching and keep learning. See you tomorrow.